guys will have to bear with me. Hopefully I won't trip and fall. So today we're here to talk about MongoDB. So everybody's talking about NoSQL databases and big data and everything else like that. So what we're really going to do is this. So here's a little bit of history about me, right? Primarily Oracle databases for a long time. NoSQL, just started that recently. And then a few other things. Specialties, I've always done like, not your typical DBA. I've always done things like more infrastructure, architecture, implementations and design. So more sysadmin type things, not development. So I've always worked really closely with sysadmins and storage guys and things like that. So a little bit different perceptive point of view. So one good fun fact about me is that I worked for EA and for BioWare, the studio, and so I got to work with Star Wars: The Old Republic MMO game. So if anybody likes games, they probably know about the game. It was a pretty big thing. But 6 months before we went live, we decided to re-architect the entire stack. So we changed the hardware from Dell to HP. We changed the OS, just slightly different versions of Linux. We changed the storage infrastructure from a SAN to an NFS to NetApp, right? So we changed all this stuff. And then we also changed things within the database itself. We changed the way that we handled the asset classes. So all of that, just basically to say that I kind of like the craziness of like go live environments and just the insanity that's involved. So NoSQL databases and big data fits right in there. So, and here we are. So this is kind of like what we're going to talk about today. So first of all, we're going to go get you like a general scalability, a little bit of history, and then an overview. We're going to talk about the explosive growth of data and where that comes from. We're going to talk about some of the options for big data, and then we're also going to talk specifically about MongoDB, scaling MongoDB. And typically I give this talk to a slightly more, a very technical audience. So I kind of do two different versions of it. One is more of an overview, but the other is more of technical. So this is going to be kind of like a combination. So if you actually care about like the technical stuff, I want you to walk away with some points and tips of different things that you can do to actually scale MongoDB. So the other thing is sharding. Sharding is scaling, but we'll get into that later. Sharding. That's a wonderful word. Everybody loves that word, right? And then specific tips and gotchas from different points of view. So I mentioned sysadmin, DBA, ops. So you'll get tips specifically for all of those. And then the very end, when I'm running out of time, we'll also talk about upgrades and benchmarking tools that you can run so you get an idea of how you're doing with these new technologies. So scalability. Look at right there, the very definition, right? I love the word because it says it all right there in it, scale and ability. And then the actual little definition is basically the ability to do everything, especially with a computer system, and scale it and grow it as you add more and more data, but more importantly, to still get the same amount of performance and ability that you did before. So you'll add hardware, you'll add whatever, right? You add the resources that you need as you come along. Okay. So there are two ways to scale, up or out, horizontal or vertical, right? So typically, back in the old days, and even sometimes today, people still scale up. That's your typical big iron that you're talking about, right? And the associated costs that go along with it. Then you've got your out, which is usually going to do either physically or virtually. So physically is obvious, you're going to add more lower cost commodity servers, or vertically, you're going to use virtually, you're going to use VMs, etc. Add more CPUs, add more resources. And then the final thing, the thing that's kind of important to allow this is the network improvements that we've had. You just heard the talk previously that was talking about networking, security, and some of those type of things. Without those changes, we would not be able to have the ability to do what we're going to do here. So the things that most people care about, why scale out? Scale up, horizontal, right? Big blue, et cetera, versus scale out. It primarily comes down to expenses. You see the additional dollar signs there. They're there for a reason, right? Big iron hardware is big. It's expensive. You add RAM, you add resources, and you just keep going up. Then on top of that, you're going to throw in the licensing costs, the software, the support, et cetera, et cetera. So then you have the slight issue where you're talking about unexpected growth versus expected growth. Sometimes, especially when you're starting out with a new application, you have no idea how fast you're going to grow, or how large you're going to grow, or how quickly you're going to grow large that fast. So anybody here work with mainframes, IBM? Anybody here used to work with mainframes, IBM, right? So back in the day, it's still in the day, right? So between 2007 and 2010, I worked at two different companies, and we both had the same issue pop up. You buy a certain level of capacity, IBM gives you a bigger mainframe than you need, and then you go to town. 99% of the time, that's absolutely perfect. But then certain times of the year, or for whatever, for example, the thing that I skipped in the first slide, I worked for automotive industry auction, the first online automotive auction when I worked for Mannheim in Atlanta, Cox Enterprises, and I worked for the University of Texas. So 2 of the times that they used big hardware, IBM, and the important times that we ran into trouble was when January auto inventory and also August class registration. So when we needed that extra capacity, it was there until we actually needed it. And then at that time, IBM, the mainframes, would start throttling you down below your actual capability that you'd contracted to pay for. So your performance would just go down into the basket very, very quickly. So it was a very bad thing. As opposed to, how about a new novel concept? Pay as you go. Pay for what you actually use for it. Allow that extra capacity to utilize something. That's actually where the whole cloud and the whole virtual thing kind of came for. So you also have the hidden costs, right? So what are we talking about hidden costs here? You not only have to upgrade your servers or add RAM or memory X at every 2, 3, 6 months, depending on how fast you're going, but you also have to go through the upgrade cycle for all of your servers. And that's not just the upgrade cycle, that's also the training and the testing time and all that type of thing. So why were they still doing that? Why? Because there's no reason. We have better commodity hardware. There are cheaper options, cheaper servers, cheaper disks, cheaper memory options, everything that you need. So first we're going to take another step back. And why are we going to talk about Oracle? Because I know a lot about Oracle. We're going to use it as an example, right? So historical scaling, we're going to use this and we're going to branch from there into into NoSQL databases. First you start with your single instance, and it's all pretty much right there. Your small server, you get local or direct attached disk, and you just kind of grow from there. Your redo logs, you put them locally so they're faster, right? Then you start, okay, you have more data, you need bigger needs, so you're going to upgrade. You get to a larger server, still a single host, and you're going to add CPU, RAM, etc. So, funny story about that, right? That works very well in your large single server environment until you work for the first online auto auction. And what happens then? You have an application that's written in Java. And what happens then? It's going to chew through your memory and your resources and your CPU pretty quickly if you don't have it tuned correctly. And what's going to make it even worse than that is if someone's using an ORM, if they're trying to use object-oriented programming and use something like Hibernate to write the queries for you, instead of them, the people who know the data, writing the patterns accordingly. Hibernate, I hope any of you guys do not work for Hibernate, but Hibernate has written some of the nastiest queries that I've ever encountered in my whole entire life. I mean, just ugly, ugly things. And to this day, every time I hear ORM or ODM, even in the Mongo world, I just cringe a little bit inside, because I know that eventually I'm going to have to deal with a really ugly query that I can't do anything about. So that's a little bit more about that. So then eventually we just keep going, right? Even larger, even bigger sands, et cetera, et cetera, et cetera. So we're all going along fine. We've upgraded. Now we've got like a massive, M6000 or whatever Sun machine, and we've got like our own dedicated storage SAN, and we're just happy as clam. But then what happens? We got more and more people going online, right? Along this time, let's see, 2006, right, is when like the iPhone came into play. It was, by 2009, it had been out for 2 years. By 2006, Facebook had been open for everyone. And we've got all this different stuff going on. You have more and more data, and then people decide they want to buy books online. Oh my God, right? Remember back in the day when people thought that there's no way in Hades that anyone would ever buy anything long-term more than just a book from Amazon. Those days are gone. So then this just goes, so then what did the RDMS world do? They broke out and they said, okay, we're going to have to scale this, and let's try to scale horizontally. So Oracle, because again, I know Oracle, we went through all this stuff. Old 8i parallel server, 9i rack, right? We got a little bit better with 10G, right? Rack actually became a usable functionality in 10G. You got the GRUD computing, okay? And the biggest thing here, HA, you could add and remove nodes on the fly. So that's happy. Then I think I started with like rack in like 10.201 in various versions, and way back on SUSE. So SUSE Linux, that was interesting and fun. But the bigger thing that we're actually talking about, so here at Golden Gate, I mentioned Golden Gate here. I actually love Golden Gate. Golden Gate probably changed the tide of like where I was going with my career, because the first time it actually was a viable replication technology that was not the biggest pain in the world to set up, and it was fairly simple, as long as you got your networking set up correctly. And this is one of the reasons I'm talking about all of these things, right? The network set up correctly. So when I was with Star Wars, or with BioWare Star Wars, we replicated user data, asset data, what you were capable of, across 3 data centers and across 3 different continents. Right. Well, 2.5 continents, but whatever. To Ireland, between California, between Virginia, and to Australia for a short period of time. So we used Golden Gate to replicate this information. We kept having this problem where the replication would break for no reason. We'd look in the logs, we'd see a network reset by peer protocol error. We'd go to networking, they'd look at their logs, and they'd say, nope, everything's fine, nothing's going on, move along here. So we'd go along and we'd keep doing this, and then it would happen again. Every time this happened, we would have to take an Oracle dump, an export, ship it over, do an import, and restart the replication. Now, when it was a 5 gig table, not a big deal. But once we got up into 300-400 gigs and we're shipping that across the wire and having to remaster while the application's still up and running and then it has to catch up, that became a big deal. So, made the network guys sit down, and lo and behold, they had not set up the network correctly after all. They had set up one-way communication, but not the two-way handshake. So, it was going fine as long as there was no hiccup. But as soon as we hit a hiccup, drop, the data went out to Never Never Land. So that's not a happy place for data to be. So what you had to do, there's this optional process, free Golden Gate tip here. There's an optional process in Golden Gate called the data pump. And what it does is it takes the trail files that you usually write and send remotely, it writes them locally so that when you have the network the splat, it would automatically know where to pick up, and you wouldn't have to do this hour-long remastering process. So the lesson and the key takeaway here, right there, network is key. So architectures, now that we're talking about architecture, well, and networking, take a look at this diagram. This is a very simplified diagram of an Oracle racking. You see your public interconnect. Probably better if I look down here. You see your public interconnect, you see your private interconnect, and then you see your storage network, your 10 gig link. You see all your lines, you're dual bonded between all of these. But what you don't see, and what I didn't put on here because there's just too many lines for me to draw, is all the lines from your individual nodes to each other and to both of the private interconnect switches. So you have this mass spider web there. And that's simple network? No, that's not. So, but that was Oracle RAC. And I actually like Oracle RAC. But the whole point of that whole little history lesson are these, the takeaways that we have, that we take, and we take with us into the NoSQL world, into the big data world, right? The specific lessons. You need redundancy, right? Data guard, failover, whatever. You also need distributed systems will give you better compute power, better results. You have flexible, scalable architectures that you can add resources to on the fly and remove. With Exadata, you had parallel processing. But now with the commodity hardwares and NoSQL databases and Mongo databases, you get these type of things, Hadoop, etc. The biggest thing about NoSQL, there are two really big things about NoSQL databases and about Hadoop and all these big data sources. You have so much data coming from so many different sources, and we'll talk about that a little bit more in a minute, but that's the primary driver. It's coming from everywhere. It's huge. It's a ton. It's a amount, and you have to find a way to mesh these technologies together. So we're going to take all these lessons that we've learned in the past and apply them going forward and worry about the costs. So there it is, big data, all this different stuff. Why do we care? We care because of the explosion of big data. That's why most of us are here. That's why you're listening to a talk on scaling, right? Because there's so much. So, and then I just had to put the slide in there because I love it, right? Are you guys out there already drowning in like the sea of big data? It's just out there. So what are you going to do? We have more and more and more that's coming. Explosive big data. So I don't know if this is the best audience for this particular slide, but I didn't take it out anyway. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everybody else is doing it, so they claim they're doing it, right? Right. So, there we go. Gartner gets there and talked about this. Gartner has their thing, global data information volumes, 59% each year, okay? 500 terabytes of data are added to Facebook every day, And this stat was from like 6 or 8 months ago. 1 exabyte of data is created every day on the internet, okay? By next year, by 2016, that's expected to go up even more. We're gonna be in like the freaking zettabytes level. So it's pretty amazing. So I'm trying not to curse here, so you guys bear with me on that too. So why do we care? The dollar signs, right? We see the dollar signs right there. It's big data. This year alone, 16.9 billion. This number here is 16.9 billion. They're expecting it to like go even higher. I saw a number in the trillions related once we get further along in this way. And it's only gonna, 2 things really. You can read the quote here, but the reality is 2 things are driving it. The explosion of social data, social media data, the explosion of mobile application data, games, etc., and the upcoming Internet of Things that's already here. There's somebody else who calls it the Internet of Everything, not just the things, because that's really what we're going to be talking about. It gives me shivers just to think about it. It's exciting and it's scary at the same time. It's just amazing, right? Just amazing. So why? What are we going to do with all this data? How are you going to handle it? NoSQL database technology is going to take care of a huge chunk of that. Between the various NoSQL databases, 7% growth, and Hadoop, 7% adoption per year. This is why these things are important. So, why are they growing? This is a favorite slide. What's driving this? This is a survey from managers, right? From development managers. And what things are important? 24% said faster, more flexible development. Why they're going there, right? 21% said lower software and deployment costs. 25% says lower hardware scaling costs, and that's primarily associated with Hadoop growth, okay? So we have this huge variety of NoSQL technologies right now. The last time I checked, there was 160 different ones out there, all doing kind of different things. MongoDB, document store, Cassandra, column store, Redis, key value pairs, et cetera, et cetera. And then developers. The old school developers versus DBAs, right? Developers want the schema list. They don't want to have to think. They don't have to force their data to go into a structure. They just want to develop and let it happen. That's actually how MongoDB, how ObjectRocket got started, because the 3 co-founders got together and they were tired of having to force data into something. So that's how they founded ObjectRocket that Rackspace bought. So developers like schema lists. They like to get to play with the cool toys, and there are more developers than DBAs. So guess who gets outvoted, right? Real quick thing here, just a quick comparison side-by-side slides. You know, it's not just the developers that have joined the dark side. I too have joined the dark side. I'm sure that Larry gets a few gray hairs over it, but probably not that many gray hairs just because of me. There's still plenty of MongoDB and other NoSQL database technologies give me plenty of additional gray hairs along the way, so payback is fun. But you see there really, it's just a collection. I'll have these slides up and you guys can take a look at it. But the bigger thing is, the point here that I like to make is the fact that unstructured versus structured data. And that's really where you come in. That's why it's important. More data types, I mentioned that in a minute. So then too, here's another great slide. Big data databases, they're here. Some people think I put this slide in just for Big Brother, but no, it's not that. It's the growth that's everywhere, right? It's, just like I said, there's a bunch of them. Here are some of the 160 available technology areas in NoSQL. If you know, probably know quite a few of them, but they're there, right? I mean, just so many. So which ones come to the top? How do you know which one to pick? How do you know which one to use? Where do you start? Here are 3 technologies, just a quick. So originally when I first developed this talk, it was going to be compare and contrast. It was going to be NoSQL technologies and all 3 of these technologies. But as I got into it, the slide deck was already way too long. So I had to do some shaving and pairing, and I'll do a separate one on this one later on. But this just tells you a little bit of the difference between all of these, right? How you use each one, just a real quick blurb between them. The current versions, but the biggest thing is they all have replication, right? They all do different things very well. Hadoop primarily for the analytics, parallel processing, all that type of stuff. But you see my asterisk, asterisk, pound, exclamation mark. And the schema list, going back to the developers. People want to just put data in there, unstructured, leave it there, right? Well, when you do that, you're making a mess. You still have to think about it. It's schemaless and it's unstructured, it's semi-structured or whatever. but you still have to think about the data. You still have to think about your application patterns, your query patterns, your flow, because if you don't, you'll have garbage in, garbage out, and your data will be nothing but a big dumpster. So now we go to Mongo, right? Here's Mongo specifically. Why Mongo, architectural overview, sharding and shard keys, but not a whole shard key thing, and then the specific details and tips that I talked about, right? Market sentiment. Why are we going with Mongo? Market sentiment. LinkedIn talks about it, right? MongoDB is the blue line in this graph that's way above everyone else. And that's because of a couple things. So things that we care about. Community support, development efforts, the languages that are associated and available there, right? According to Database Engine, it's number 4 on all the databases. This is like, even with Oracle, IBM, DB2, MongoDB is number 4. In a short period of time, 5, 6 years it's been around, that's pretty amazing. You see there, 163% growth in the last 2 years alone. So as more and more efforts are being made, and I used to kind of say, MongoDB is going to grow up and become a big boy database. Well, it's already becoming that. It's been that. And it's got some great functionality. It's got some things that it does really well. It's got some things that it still needs to work on and do well, but that's every database technology, right? So the fact that it has the community support, that's what's going to help, and that's going to help everybody do. So what is it? The bigger thing, sharding, scaling, that's what we're talking about. MongoDB has built-in support for scaling, for horizontal scaling, through the replica sets and via sharding. High reads, heavy writes, heavy reads do good, do very well, right? It handles heavy writes very, very well. If you have high reads, it can handle that on a linear scale. But if you have high reads and high writes both, then you're going to have some give and take. You're always going to have that. And we'll talk about a little bit more about that with shard key. What's it good for? Log data, event data, sensor data, right? All of these different types of things, that's what it's good for. You can do pet projects on it. You can take your Nest thermostat and graph what's working and not, just for fun, of course. And then user data and game data. A lot of games and a lot of user data, a lot of social media app data, all these type of things are good for Mongo. So notice at the bottom I said eventual consistency. That's one thing that you do have to remember, the difference there's between a relational database and this MongoDB, right? Eventual consistency. It's only going to eventually be consistent. And that's more true as it replicates to the secondaries. So here we go. Basic architectural overview. Most people probably realize this, but it's fairly standard. For your single replica set, that's your basic MongoDB. You get a primary, and you get 2 secondaries, or you can have 5, or you can have 4 secondaries. But the big thing you need to remember is you want an odd number. Talks via heartbeat. You see the heartbeat there, between there? Who's up, who's down, who's primary, who's master, who's primary, who's secondary, etc. Oh, did this server just have a problem? Let's change, okay? And then replication occurs out to the secondaries via the op log. So if a change makes it to the op log, it's going to make it to the secondaries, you hope, right? Sharded clusters. So this is what scaling is actually all about. This is how you do it. You take your single replica set, and then you add another replica set, and another replica set, and those all constitute a shard. So, your first tier is your Mongo S tier, right? Well, let's start at the bottom. Your MongoD tiers, right? Those are your datas. And as I mentioned before, you've got your shard 1 with each of your primaries, your secondary, et cetera, et cetera, et cetera. Then you've got your config data, right? I like to think of those as the data dictionary of Mongo. And that's where all of your information goes about where the location, where the chunks are, which data is stored where, how do you get to the data that satisfies your query. That's all stored in your config servers. And then your Mongo S tier is your query router, your traffic controller. It's gonna talk to both your configs and your MongoDs, and it's going to know where to go to get the data. So all of that's very important for one simple reason, right? If something happens to your config server, how is your data, how are your Mongo S layer going to know where to go to get the query satisfied? So that's important. Okay. So sharding, what is sharding? Not just the shards that I showed you a second ago, but what is sharding? Sharding is horizontal scaling. That's what it's all about, right? It takes that and it distributes it across all the nodes. It increases your ability to read, to write, and it kind of just takes it from there. You can, with MongoDB, as long as you're setting things up correctly, you can keep adding shards. So that's kind of how that part of that goes. Okay, the thing that we're not going to talk about, sorry, had allergies this week. We're not going to talk about shard key selection fully, but I am going to mention some of the important tips about this, because that's just the most important thing that you can do is pick your correct shard key. If you don't, you're in big trouble. Big trouble, big trouble. So how do you shard? Select the best shard key. Notice here that I don't say select the shard key. I select the best possible shard key, because again, you're going to have trade-offs. We'll talk about that again. Create your required index, because it requires an index that supports the shard key that you select. Enable the sharding at the database level. Then you shard the collection, which is a command within Mongo that you use, and then you're going to add the shards. Here's some sample commands for each of those, right? You look at them. You create your index, bam, used users, DB users, it's your index, off you go, hashed, enable sharding, and then shard your collection. Easy, right? Not quite so fast. There are things that you have to think about when you're picking your shard key. Again, this is not a deep dive, but there's some very quick things. If you pick a good shard key, you're going to have good performance. If you pick a bad shard key, you're going to have bad performance. Shard key collection is the most important thing you can do when you're scaling with Mongo. Very important. There's no perfect one. You're going to have trade-offs. For example, user data, social media apps, game data, this type of thing. Everyone thinks, okay, great. Shard key equals primary key. No, not really. Shard key helps you distribute the data all across there. But if you think, okay, user ID would be a great primary key in a relational database, but if you pick user ID for your NoSQL database and use that as your shard key, you can run into hotspots in both read and write. Because think of this, you have one user that's much more active, you have one blogger that's much more popular, and everyone goes to that particular blog to read the blog. All the activity is going to go to that blog. All the activity, all the associated activities that you write about get written into for that blog, and then the chunks within MongoDB underneath the covers that basically equate to extents grow larger than they should, and they all sit on the same shard, and then all of a sudden you're hotspotting. When you write, they're all going to the same shard. When you read, all the queries go to the same shard. So it's not the same as a primary key. All right? Immutable. Shard key has to be in all documents, first of all. Can't have nulls for a shard key. Okay? And immutable, you can't change the value of a shard key once it's been created. Okay? So the biggest thing here, again, there's no perfect shard key. Right? You're going to have to give up something. If you know your application is 90% writes, then choose a shard key like _ID : hashed that gives you the best write distribution across all of your available shards. If you know your application and the way that you make your money is going to be based on the reads and the queries, then you're going to choose a shard key, possibly even a compound shard key, that will help you narrow it down to best going to the single shard that's going to represent and bring back the query results that you want. So there's all these different considerations and things that you have to think about so that you don't. Then there's the balanced distribution too, right? So the other thing is the jumbo chunks. Jumbo chunks in MongoDB are a thing. So MongoDB will split these jumbo chunks, but sometimes jumbo chunks 64 meg are higher, right? That's the cutoff, that's the default. So MongoDB will split these for you sometimes, but sometimes they just sit there and grow. One time I've had a 32 gig chunk for in a single collection, all on one shard, on a sharded collection. So imagine the imbalance at the disk level. It's not just within the query engine, it's also for your disk storage and your capabilities, right? So you want something that's easily divisible, you want cardinality, just all this kind of stuff, right? The other thing, when you're going to shard, say you have a 10 gig instance, and you decide you've got a 3 gig collection, and you're going to shard that collection, but you're already up to 9 gig. Then you start sharding. You shard the collection, MongoDB starts balancing and moving the chunks, distributing across there. But you're already running out of space because it's going to leave those empty segments, extents there, even after it moves and deletes them until you do something else. So shard early, shard often. There's also the fact that when you shard a collection, it's going to have an impact because MongoDB underneath the covers has to go in, figure out all your split vector points. You know, hey, where am I going to divide this chunk? What's going to happen here? Okay, this one's going to go from number to the number, right? It's going to split it all out. So that's going to take resources and time, so don't wait till the last minute because your application will freeze and it'll hose and you'll be in trouble. So, let's see. There we go. When I'm doing shard, so I actually do quite a bit of time selecting, for our customers, selecting shard keys. And so there's always some basic questions that I ask, and here's what some of them. There's a thing called profiler in MongoDB. It's not, well, there's a thing called profiler in MongoDB. So you can enable it to gather all queries, which is what we do when we're doing a shard key selection. So every query that comes through the database, it's going to do there. And then we analyze the patterns associated with each and every query to try to help us determine the best shard key. Because most of the time the customers come in, we don't know their application because they're customers, right? And they don't know their application because a lot of them have just started using Mongo and they've just developed this application. So by doing this, it allows us to take a look at that and learn what that is, right? So do these things, find your predicates, find your patterns, find your predicate options, check for nulls, et cetera, et cetera. Basically, you want a sample representative query pattern set for a typical activity level. And then you also want to know some of the things that happen when it's not so common. So we talked about that we're going to have different tips, right? Different tips from all these different points of view. So DBA tips for managing scale, besides the ones that I've already thrown in there, right? Even when you're operating after you're sharded, keep your profiler set to slow. Why? Because then it stores in each database in your instance, it stores all queries greater than a certain percentage, a certain number of milliseconds. We keep ours at 100 milliseconds. So any query that happens that takes over 100 milliseconds to go is in there. And then we can take a look at that. That helps you look at indexing, where you need to add indexes, where you have bottlenecks, what things may be backing up everything else, et cetera, et cetera. The other thing is, by default, that collection is only set to 1 meg. If you're a super busy application, 1 meg will last less than like 1 minute for some of our clients. So what we generally do is we set it to 100, set to 100 minimum, right? And then, so here you are here. If you don't set that profiler on and enable it to 1, because there's a small bit of overhead that happens with that. But when you set it to all, there's more of an overhead, so that's why you want to do it during a limited time period, a shorter time period, but it's important you get all the patterns. But when you set that to 1 to do it at all, if you don't do it, there's no alternate way to get slow query information. It will actually store that in your MongoDB logs, but most of the time, or a lot of times, it cuts off the query, so you never get the full query pattern. So that's one of the reasons why you want to actually set it. So anyway. Queries matter. Turn them. Queries always matter. Whether it's relational, non-relational, whatever. Queries matter and query patterns matter, right? Those nasty hibernate queries. Ugh. Yeah. Okay. Anyway, sorry. Goldilocks indexing. In Oracle and some of these other things, the more indexes you have, the more resources you have to write to update the indexes. And that's also the same kind of way with Mongo. It's not as bad, it's a little faster in Mongo, but it's still true. So some people say index everything and figure it out afterwards, like God sorted them out, whatever. But I like to try to work at it along the way, just to, it's just a bad thing. Too many, both too bad, right? Both too bad. So the 2 asterisks on the next 2 bullet points here, well, one bullet, yeah, both. Up to 2.4.0 and parts of 2.4.6, up to 2.6.4 version, you needed to build indexes in the background, and you needed to build indexes. We used to do it using a secondary index build method. And the reason for that is if you do it in the foreground on a 2.4 database, Mongo database, and you don't do it in the background, it does it in the foreground, then it'll start building, it'll build on your primary, then it'll start building onto your secondaries. And if that's on a collection like anywhere over 2 or 3 gig, it will freeze your application until it completes across all of your primaries and all your secondaries. So to get around that, what we've done is the secondary index build. You have a 3-member set. You take one secondary out of the replica set, start it up standalone mode, build the index there, add it back to the secondary, add it back to the replica set, let it catch up for the op log, because if you don't do that, you're in trouble. So do the same thing for the second one. Take it out, add the index, add it back in, wait for it to catch up, right? And then do a step-down election to make a new primary. So then you take the old primary out and do the same thing. In 2.6.4 and above, in 3.0, you can supposedly not do that. But Testing has not totally proven that out to be true, so we're still using the safe but sorry method. Better safe than sorry method. In 3.0, we're currently doing some testing with Mongo 3.0 with and without the Wired Tiger. There's a lot of bugs that are still out there with Wired Tiger with 3.0 that we're working through and testing on. So anyway, background and secondary. Know your application's behavior. Know it all the time, not just when you profile it the first time, right? Know it, check it again every time after you do a code change, because that's when a lot of things normally break with any database technology. Reevaluate, reanalyze your queries. If any of that changes, your access patterns can change, and an index that used to help you quite a bit may no longer be any good. So those are those important things, right? Still there, yes. Monitor always everything. So MongoStat is a tool that, one of the few tools that MongoDB has that allows you. Unlike Oracle and some of the others, it still doesn't have all of the, like you could see the mutex latches and all these different things into the memory engines for Oracle and some of these others. MongoDB is slowly getting there. It's adding some functionality, but it's not quite there yet. So I'll be very glad when we get to that point. But know what so one of the tools that you do have is a MongoStat. Know what your MongoStat looks like. Know what your results look like. Know how many queries you're doing per second. Know how many deletes, know how many connections, all this different stuff. Watch for your high DB lock percentage in any version up to 2.6. 2.6 and above, they changed the stat. Now there's a dirty percent that basically equates to percent disk dirty. So then you have to look for queued reads and things like that to tell what the performance. We used to look at DB lock percent, and that would tell us when you're reaching your right threshold and when you needed to add another shard. But that's changed. So workloads. Some people say, yay, I've got Mongo. Yay, I've got a Mongo instance. I'm going to start this database and this database and this database. And I'm going to do analytics, and I'm going to do aggregation, and then I'm going to do my normal application running, all in the same instance. And then they wonder, why is this going so slow, right? Separate, some people say, okay, it's fine, it's different databases. Okay, you'll get a few additional write scopes, right? Because you've got different files, but you're still sharing the same resources of the same instance. So separate your workloads out into different instances. Okay, chunk movement. So when you're balancing, right? When you shard it and you're balancing out your chunks across all your different shards, those chunk moves take time. So know how long it takes for each of your sharded collections in general for a chunk to move. So that if something happens and all of a sudden this chunk that used to move in 1 minute for this collection is now taking 15 minutes, you can take a look and see why. We've had some people who they have clients too. So they're clients of ours, and then they have clients. And their clients did a runaway system, a runaway changed the application, flooded their instance in our environment. And then we have to figure out by looking at things like chunks. Oh, well, you just added an additional field with 200 subarrays in the document, like subdocuments, this kind of thing. And that's the only way that you can kind of figure that out, right? So be careful too, mass deletes. Everybody thinks, okay, MongoDB is great at writes. I'm going to write and then I'm going to delete. When you delete data in Mongo, at this point, it doesn't clean it up correctly, smoothly, cleanly under the covers. And that's one of the reasons why we do this thing called a compaction, where we take a secondary member out, we blow it away, we rebuild it from an initial sync to get rid of the fragmentation at the disk level. Now, in Mongo 3.0, they have some new things that are supposed to help with that fragmentation. But I'll let y'all know more in a couple months because we're doing the testing. So, when you have to do a lot of deletes, right? So going back to mass deletes, MongoDB is write preference. So when you're doing the deletes, if you're querying the database at the same time that you're doing all these deletes, which one's going to take precedence? Your deletes. So you have to come up with a methodology to do loop deletes. Write a for loop, do some sleeps in there to allow time for queries to actually come in and be satisfied in between all of your deletes. Another thing that you can do is look at using TTL indexes, time to live indexes. So I've got a whole nother presentation out there on time to live indexes. You look on the slide deck, and it's got some math and all this stuff. It's titled Math is Hard, right? Because the first time I was trying to wrap my head around this when I started first doing the Mongo, I was like, bam, 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 rock. And then it's like, oh, okay, that's it. So hopefully this will help you guys. But even with TTLs, if you turn off your TTL, so we had an application, we had a customer that turned off his TTL because TTLs can have a little bit of an impact. And he was very busy. It was during Super Bowl season, and he was somewhat associated with something that happens when people go to the Super Bowl, right? So it's a social type thing. So he turned it off, and then when he turned it back on, it hammered his system because it has all these catch-ups to delete. We had 240 million deletes that we had to get up to catch up just to get him caught up so he could turn on his TTL index again. So that's another thing. When you're using TTL indexes and you're using any kind of social media type application that's busy on the weekends, build in an inset. Instead of 7 days, instead of having a week long, make it 10.5 days so that you don't get hammered on Saturday morning or Saturday night when you're busy for the deletes that you wanted to do from Friday night, right? I don't know how much of any of you guys you know about Mongo, but find and modify. Find and modify to me is kind of like the hibernate of MongoDB, right? It's ugly. I mean, it is. It has its purposes. Only use it when you have to. But basically what it does, it goes out, it finds your document based on the search criteria that you need. It puts a database level lock on it, so it locks the entire database, not just the collection you're doing, not just the field that you're doing, right? Not just the document. It locks the whole thing, brings it back into memory, makes the change, sends it back, does not release that lock until everything else is completed. So imagine if you had 200 find and modifies that were supposed to take 1 second each, and they start banging up behind each other. Next thing you know, you've got a 70-second find and modify. Yuck. Yeah. So ask Asia. So she's one of the MongoDB people, pretty high up, does a lot of talks. She's got a great blog on there. It does kind of sugarcoat it, but it is a great blog on that. So, all right, all done about the DBA side. That means I need to hurry. Hardware and OS settings. CPU speed is more important than core count, right? RAM is important, but it's not the most important thing. Disable A time for file volumes. I'm going to skip through some of this to the most important stuff, right? Because you guys, again, this will be out there for you. Open file limits. Just like any other database, open file limits is very, very important. Your number of procs and your open file limits, right? And ulimit -n 6400, ulimit -u 6400, make your changes. If you do any kernel updates or changes, restart your MongoOS. Don't wait for 3 months until you have your next restart, because then you have a problem pops up and you'll have trouble figuring out where it is. Replica sets HA, use 3 or 5, right? Separate your primary and your secondaries onto different hosts so that you have high availability. The biggest thing there, set read ahead correctly. That's very, very important with databases like Mongo. By default, it's set to 256, right? Change it to much, much lower. This has a great impact in a good way on your system. Mark Callahan has a great blog out there, right? And that's the link for that, right? These are common sense things. The biggest thing that I have to say here is allow your balancer to run. When the balancer runs, there is some impact as it balances the chunks across all your shards. So you can set a balancer window to allow that to happen. But the biggest thing is allow the balancer to run. Otherwise, you're going to end up with one shard that's 800 gig and all the others are 100 gig. And you're going to wonder why you're having performance problems. Allow the balancer to balance things out. The compactions and compressions that I talked about, get rid of the fragmentation. Fragmentation negatively impacts your performance as well, so that's important to do. Make sure that your application handles reconnects well, because every time we take one of these secondaries out and we do a step down, not for the secondaries, but when we do the step down to elect a new primary, there's going to be a 5 to 15 second period of time when connection exceptions occur. As long as your application and your drivers handle that gracefully, they'll retry and everything will be fine. But if you don't have that set up correctly, you're going to have to restart everything on your end. Excuse me. Okay, the last big thing here, update your drivers. If you're using the old version of the driver that can't handle the reconnect logic well, you're going to run into trouble. So, okay, upgrades. Test fully, test carefully. Paranoia is OK1, right? It's extremely important that you test for your upgrades. When we have a large client that we did an upgrade from 2.4.10 to 2.6.4. Within an hour, we rolled back because the performance was so bad. 2.6.5 apparently was a version that everyone needed to go to because 2.6.5 and above was better. But because 2.6.4 took so long to come out, 2.6.5 took longer, we actually never went to 2.6 anything for the majority of our clients because of the performance matter. 3.0 is a different matter because it's coming out so much closer. But if your application is any way possible pushing the edges, if it's friend cases, if it causes all these trouble, make sure that you test. Here's some of the reasons, problem specifics that we ran into, right? In case you care, these are the actual bug numbers. The biggest thing you see there, out of memory errors, right? That means the server crashed, okay? Roll back to a stable version. All these different things, right? So these are all just things that you can read later. So as again I said, we're getting ready to go to 3.0. Most likely without the Wired Tiger change to start out with, we'll stick with the Nmap because of the fact that there's still so many outstanding bugs with Wired Tiger. There are also quite a few other engines out there right now that are in play. You know, Toku, just bought by Percona, that's a compression engine that's also similar to Wired Tiger. And then you also have Facebook is doing RocksDB engine. So all these different engines. The one thing, before you go from a 2.4 version to a 3.0 version, you have to at least go to 2.6. So make sure that, because there's schema changes, there's auth changes, which is the biggest thing, right, the auth changes. But there are also log file changes, all this different stuff. If you've used an index that is too long, linked too long, before in 2.4 it would warn you, in 3.0 and 2.6 it will actually fail. And then you can't find your data because the index is not there. So that's some of that. Benchmarking tools. So I mentioned benchmarking tools. Here's some great benchmarking tools. You know, SysBench, MongoDB, Tim Callahan's got that. We use that for generic application testing. YCSB, a lot of people like YCSB. I happen to like SysBench a little better. And then Flashback is a new one by Parse, which is from Facebook, where it actually is like similar to Oracle Real Application Testing. And what that does is they take a sample snapshot of your actual data, your actual live production data, and then you can replay it. So it's not quite as sophisticated, and there's still some kinks because some people, Parse still uses single replica sets, right? Meaning they scale vertically, which means they're still paying the high hardware costs, et cetera. So links to that, links to all of this is here. So that's pretty much what I've got there. In closing, RDMSs are not going away. They're still like 48% of the market, but 48% is not 70%. And meeting the needs, you know, NoSQL needs, you know, Hadoop, just so many interesting things out there. MongoDB is just, it's been able to just take a large part of the market share. So it's a great thing. So, and more companies, two examples of companies that have moved away, right? You've got, there's a digital marketing company that moved a whole bunch of data to Hadoop RDMES, and it's running 3 to 7 times faster, and they're saving, it's like 75% move from Oracle. AMD had a massive outage, 276 terabyte that they moved over from Hadoop, from Oracle to Hadoop RDBMS. All these things, more and more companies are moving away from the traditional RDBMSs. So, thank you guys. If you have any questions, I'm available later. Andy Woodard, he's our migration manager. He was originally going to help out with this, but the migrations part kind of got shoved to the side. So if y'all have any migration questions, he's over there. So thank you guys.